All right, so now that we finished learning everything in this subchapter, it's a good idea to do some practice. So why don't you go pause this video and solve some of these questions? You ready? Okay, so the limit as x approaches negative 2.5 from the left-hand side of f of x equals, well, what does it equal? We see what the function's approaching from the left-hand side, okay? We see that it's approaching negative 5. All right, so now let's look at what this question's asking us. The limit as x approaches negative 2.5 from the right-hand side of f of x is, well, let's see, what is the function approach? So we look from the right-hand side, we see the function's approaching negative 2. All right, now the third question is asking us, what is the limit as x approaches negative 2.5 of f of x? So see, this doesn't have any direction in it, so this means this is a two-sided limit. And because the left-hand side and the right-hand side limit are not equal, we'll just say that the limit doesn't exist or is undefined. So now, this question is asking us the limit as x approaches 1 from the left-hand side of f of x. What is that? Well, let's see. Let's see what it equals. Let's see. Okay, so f of x is appearing to go up to positive infinity as we get closer and closer to 1 from the left-hand side. Okay, now let's see what this question is asking us. What is the limit as x approaches 1 from the right-hand side of f of x? Okay, so what is this function getting closer and closer to as we give values of x that are closer and closer to 1 from the right-hand side? Well, we see that this function also approaches infinity, okay? So now, what is a two-sided limit? What is the limit as x approaches 1 of f of x, all right? This is a two-sided limit. And because these two are both infinity, we're just going to say that that limit, this limit, is equal to infinity also. Did you get that right? Let's move on to the next question. All right, so now the next question is, evaluate the limit as x approaches 0 of sine of 1 over x using a table. You can use as many columns as you, as many rows as you want, but I'm going to be using 10 for my solution. Go try that out. Pause the video and give it a shot. All right, you ready? So these are the following x values I'm going to use. I've written it down in my notebook. Negative 0.1, negative 0.01, negative 0.001, negative 0.0001, and negative 0.00001. Then positive 0.00001, 0.001, sorry, 3 zeros, 0.001, 0.01, and then 0.1, okay? So let's see, at this negative 0.1, fx equals 0.5440. Then negative 0.01, fx equals negative 0. All right, fx equals 0.5064 at x equals negative 0.01. At x equals negative 0.001, fx equals negative 0.8269. At negative 0.0001, f of x equals 0.3056. Okay. At negative 0.00001, f of x equals negative 0.0357. All right. So now at 0.00001, f of x equals 0.0357. At x equals 0.0001, f of x equals negative 0.3056 at x equals 0.001, fx equals, sorry, 0.8269. At x equals 0.01, fx equals negative 0.5064. And at x equals 0.1, f of x equals negative 0.5440. All right? And what's interesting is it's kind of unclear what f of x is approaching. Even for like super small values, it's still not obvious what f of x is approaching, or sine of 1 over x. And the thing is, you can't actually plug in x equals 0 into this because that's just undefined. 1 over 0 is undefined. So even if we use the tabular method, we still can't find a specific value that f of x converges to. And the thing is, this limit doesn't exist. All right, we just prove that using the tabular method because this function isn't approaching any definite value. And if you graph the function sine of 1 over x, you'll see that it oscillates a lot, like for values close to x equals 0. So that's the reason why the limit doesn't exist. It's always oscillating between negative 1 and 1. It doesn't approach a singular value. So that is exactly why there is no limit. The limit doesn't exist when you let x approach 0 for sine of 1 over x. Okay, so now, finally, the last practice question. Evaluate the limit as x approaches negative infinity of sine of 1 over x. Okay? So, why don't you give it a shot? Pause the video and give it a shot. Ready? Okay, so if you want to use the tabular method of evaluating limits at infinity, or in this case, negative infinity, what you're going to do is you're going to plug in values that are like really, really big, or in this case, really, really small. So I'm plugging in these values for x, and then we can just see what f of x approaches, okay? So what I got is negative 0.0998, negative 0.0100, negative 0.0010, and then negative 0.0001. Okay? So, see how these numbers are, well, they seem to be approaching 0, all right? So, we will just say that that limit as x approaches negative infinity of sine of 1 over x equals 0. And yeah, that is correct.